Hello. Today we're going to go ahead and take a look at some of the elements you need to understand in graphing sinusoidal equations, sines and cosines. So we're going to take a look at amplitude, period, and frequency, the horizontal or phase displacement, and the vertical displacement or shift. Okay, let's take a look. Okay, so we're going to use this equation as our example to start to figure some of this stuff out. So first, let me let you know the parent equation looks like this. Y equals A sine B of theta minus C plus D. So our A is the amplitude, and amplitude is defined as the distance up or down from the axis of symmetry. So in a sine wave that hasn't been adjusted at all, our axis of symmetry is the x-axis, and the distance from that x-axis to the highest point or the lowest point is your amplitude. And the reason we can say highest or lowest is distance is always defined as absolute value. You cannot have negative distance. All right, so then the way we find distance is by taking the highest point, subtracting the lowest point, and dividing by 2. Max minus min over 2. And so in a non-translated sine wave, our maximum is 1, our minimum is 1. 1 minus minus 1, that's 1 plus 1 or 2. 2 over 2, that's 1. And so in a non-translated, our amplitude is 1. However, in this sine wave, our amplitude is 4. So that means wherever our axis of symmetry ends up, we will go up a distance of 4 and down a distance of 4. Our B in this parent equation is defined as 360 degrees, or 2 pi if you're in radians, but I see here it's 10 degrees, so I'm in degrees, divided by my period, which means I can also know that my period is defined as 360 over b. So in my equation, I can see that my b equals 3, and therefore my period will equal 120 degrees. Now, period and frequency are related. Period is defined as how many degrees does it take to complete a full cycle of my wave. So in a non-adjusted sine wave, it takes me 360 degrees before I'm ready to start again. If my period is only 120 degrees, then that means I'm going to accomplish 3 waves within a 360 degree period. Something like that. If period is defined as the number of degrees it takes to complete a full cycle, frequency is the inverse of that. It is the portion of a cycle that you accomplish in each degree. So period and frequency have inverse relationships. If my period is 120 degrees, my frequency is 1 over 120. I complete 1/120th of a cycle per degree. My C is defined as my phase displacement or my horizontal shift. And one thing I want you to notice is that the parent equation defines it as theta minus C. This is that situation where whatever your C is, it moves it in the opposite direction than you would imagine. If I am looking at theta minus 10, right? That minus, it makes it look like that would be 10 degrees toward the left. It is the opposite of that, because in order to have theta minus 10, my C was positive 10, and that means I am moving it 10 degrees to the right. My D is my vertical displacement. It says plus D. Now, why would it say minus C and plus D? Here's why. this D is an independent agent. It is not part of this value right here. I could subtract D to the other side of my equation, and now I'm consistent. Y minus D and theta or X minus C. But in order to make this a y equals, I have moved my d to this side of the equation. And that is why the vertical displacement is exactly as intuition would tell you. If it says +7, that means up 7. If it says -7, that means down 7. Whereas my horizontal shift is the opposite of how it looks. If it says -10, that means 10 degrees in the positive direction. If it says +10, that must have been -10, which means I'm moving to the left. So just remember, on the horizon, it's the opposite of what intuition would tell you. In the vertical, it's exactly what intuition would tell you. And now I have enough to go ahead and graph my equation. So before I erase all this, this might be a good place for a screenshot to remind you what these things are. So again, I'm going to make my 4 columns to help me figure out what points I'm plotting. And my 2 middle columns are going to say my essential X points that I want to know are 0, 90, 180, 270, 360. And in a sine wave, I know that those will give me outputs of 0, 1, 0, -1, 0, right? That's my parent sine graph. Now I'm going to look at the adjustments on both sides. So on this side, if what I want to be my 3 theta minus 10 is 0, then I go ahead and set 3 times theta minus 10 equal to 0, and I solve. So 0 divided by 3 remains 0. Solving for theta, I add 10 to both sides. So to get a 0 within 3 times theta minus 10, I plug in a 10 degrees. I do that again for 90. 90 divided by 3 is 30. Add 10 to both sides is 40 degrees. And now I can see I'm going up by 30 for each time. So rather than having to solve this out each time, I can just keep adding 30. And to verify that I'm correct, I can check that from 10 degrees to 130 degrees is 120 degrees, and that's my period. So I've done this correctly. So those are going to be my inputs. And now to find my outputs, I go ahead and take these outputs and run them through the mill of, if the sine 3 theta minus 10 degrees part of things is 0, then 4 times 0 remains 0, plus 7 becomes 7. And now I do it again. If the sine 3 theta minus 10 degrees part is 1, times 4 is 4, plus 7 is 11. My 0 will be a 7. My minus 1, well, I can do this another way if I want as well. If 7 is my sinusoidal axis and my amplitude is 4 up from that, 11, or 4 down from that, 3, and then finally my 0 again is 7. And so this column is my X or theta axis. This column is my Y, and I can see that my sinusoidal axis is going to be here at 7. So now I can plot. So there are my 5 points. There is my sinusoidal axis between 6 and 8. So I've got 10, 7. I've got 40, 11. I've got 70, 7. I've got 100, 3. I've got 130, 7. And that is my sine wave translated like this. Okay, let's take a look at one where we were given information and asked to create a graph from it. Graph a cosine wave with a frequency of 1/12, an amplitude of 7, a vertical shift of -5 units, and a phase displacement of -4 degrees. All right, here we go. Let's start filling things in. So A, amplitude, amplitude of 7. Frequency of 1/12. Well, we said frequency and period are inverses of each other. So that means period equals 12. And we also know that B equals 360 over the period. So B is 360 over 12, or 30. So that goes there. A vertical shift of -5 units. Vertical shift, that's out here. And vertical shifts go exactly as we imagine them. Phase shift of -4, theta minus -4, theta plus 4. And so this is our equation. Now let's take a look at graphing it. Okay, so our middle two columns, again, those are our standard points. 0, 90, 180, 270, 360. And in a cosine, right, 0 starts at 1 and goes 1, 0, -1, 0, 1. If you have not memorized the middle two columns for your cosine and your sine graphs, do that. It will help you so much. Okay, so now we go backward in this direction and forward in this direction. So from here, so to go backward, we set this equation equal to each of these to find out what theta we would want to plug in. Divide by 30 remains 0. Subtract 4 from both sides. -4 degrees. Do it again for 90. 90 divided by 30. 3 equals theta plus 4. Subtract 4. And now we can see we're going by 3 degrees, so we can keep going like that. This is a really teeny tiny little period, but again, we can see going from -4 to 8, that is the period of 12 that we said we had. Okay, and now to move forward from here, we're going to take this one output, multiply it by 7, and subtract 5, gets us a 2. Do that again with 0, gets us -5. Do that with -1, that's a -7 minus another 5. Do that again with 0, and finally again with 1. And so again, we can see our axis of symmetry, right? The 0 line is -5, and down 7 from it gets us to -12, and up 7 from it gets us to 2. So we can see that we're doing everything right. And now we can finally graph it. And there is my cosine graph from high to low, back to high, translated like this. Okay, play around with these. Leave any questions or comments in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.